All right, stoichiometry of gases isn't any different than any of the other stoichiometries we've done. We're still going to be looking for the mole ratio. All right, so if I pull up my mole bridge, we're still going to be looking for the unknown ratios. Okay, so with that in mind, let's start. First, we need a balanced equation for zinc plus hydrochloric acid. Zinc plus hydrochloric acid gives us zinc chloride and hydrogen gas. All right, now we need to balance that. We would need 2 hydrochloric acids in order to balance that. What is our known that's given in the next problem? Well, we're given zinc. So zinc is going to be our known. We're given a mass of zinc. So first we're going to change to moles. So we're going to start with 2.36 grams divided by the molar mass of zinc, which is 65.39. .36 divided by 65.39, 0.03609. Okay, if we look here, zinc is our known. Our unknown is hydrogen. So we're changing to hydrogen, moles of hydrogen. So we will multiply by the ratio. We have 1 hydrogen produced for each 1 zinc that we use. So it's a 1-to-1 ratio, so our hydrogen amount will be the same, 0.03609 moles of hydrogen. Now, step B says calculate the volume of the hydrogen gas. To find volume of hydrogen gas, we're going to use the ideal gas law, PV equals nRT. The pressure in this case was given at 767 millimeters of mercury. So P equals 767 millimeters of mercury. I'm going to change that to atmospheres because I just like atmospheres better. That's going to give me 767 divided by 760, 1.009 for my pressure. So pressure is equal to 1.009 atms. All right, for volume, that's what we're solving for. The number of moles we just found, number of moles is going to be 0.03609. R is given, since we're using atmospheres. For R, we'll use 0.0821 liter atmospheres over moles Kelvin. And our temperature is given at 22. We have to convert that to Kelvin, which would be 295 Kelvin. Now we just plug and chug. We're solving for volume, so we're going to do nRT over P. 0.03609 moles of hydrogen times the R value, 0.0821, times our temperature, 295, divided by our pressure, which was 1.009 atmospheres. Okay, and you can punch the numbers in. Number 3 gives us the chemical formula for propane combustion. What volume of water vapor? So our known is going to be propane, and our unknown is going to be water vapor. So we start with 3 liters of propane. All right, we need to know moles in order to go through our mole bridge. So the first thing we'll do is we will solve for moles. Moles is equal to PV over RT. This is our volume. Our pressure is at standard temperature, so our pressure is 1 atmosphere. R is 0.0821 liter atmospheres over mole Kelvin. And of course, temperature is going to be 273 Kelvin because, again, STP. I do the math. 3 divided by 0.0821, 273.1338 moles of propane. What is my ratio of propane to water? Well, it's a 1:4 ratio. So I'm just going to take that value, multiply by 4, and I get 0.5354. 0.5354 moles of water vapor. Now I just go back and solve for volume. Volume is equal to nRT over P, so I'll take my moles times 0.0821 times my temperature, which is standard temperature, 273. My pressure is 1 atmosphere. Once I've done that, I'm going to get times 273, 1780. Okay. Next, same story. Carbon monoxide will burn in the air to produce carbon dioxide. What volume? This is what we're solving for. This is our unknown, and this is our known. All right, we have a temperature of 19.8. We'll add 273 to that, and our pressure is in atmospheres. So let's first figure out how many moles of carbon monoxide we're going to have. Moles are equal to PV over N, or RT. So our pressure is 0.976 atmospheres. Our volume is 3,500 liters. R is 0.0821. And our temperature is 292.8 Kelvin. (142 moles. That's a lot. 142 moles. Our ratio of carbon monoxide to oxygen is 2:1. 2 moles of CO to 1 mole of O2. (142 divided by 2 gives us 71 moles of oxygen. Again, we're going to find volume. 71 moles of oxygen times gas constant times our temperature, which is 292.8. divided by 0.976 atmospheres. Oops. 1748 liters. All right. Last one, we're going to change grams to moles for iron. Okay, that'll give us moles of iron. Our ratio of iron to hydrogen is 3 to 4. That'll give you moles of hydrogen. Now we just plug and chug into our equation. We're at STP, so we're going to have our standard temperature is going to be 273 Kelvin. Of course, R is R.0821, and our standard pressure is 1 atmosphere. Thank you.